Starship is the most powerful rocket ever. It is going to take humans to Mars for the first time ever, and it is the rocket that will mark the start of the human expansion of the galaxy. This rocket assures us that if Earth blows up or whatever, the human race continues. But first, we need that Starship doesn't blow up. Okay, so how do rockets fly? You probably recognize the typical picture of a rocket with fins at the bottom. These fins are used to keep the rocket pointing up, to keep it stable. But they make the rocket weight more and add drag. That is why modern rockets ditched fins, and instead a technique called thrust vector control is used. Thrust vector control consists of rotating the motor of the rocket to the opposite direction that the rocket is tilting towards. By doing this, the thrust goes a little bit sideways, and this sideways force rotates the rocket, keeping the rocket stable, pointing at the desired angle. This way, rockets don't have to waste weight on fins. Okay, so thrust vector control is good and all, but there is a slight technical difficulty with this technique. The motor needs to be continuously rotated to create an opposite force to the tilt of the rocket, so that the rocket stays on course. This balance is very difficult, because the degree of rotation the motor needs to have depends on a lot of things: the rotation speed of the rocket, the angle of rotation of the rocket, air resistance, the thrust force of the motor, and more. So, to solve this problem, very smart people create an advanced algorithm that takes all these things into account and reacts accordingly. But I ain't no NASA scientist, so why think when AI can think for me? So, how is AI gonna solve this for me? Easy peasy, let me explain. I am gonna create a neural network. Neural networks work like a brain. So you have neurons and connections between those neurons. The purpose of neurons is to just temporarily hold a value. You have a first layer of neurons. This first layer is just the data you put into the neural network, so that it has an idea of what is going on. In this example, the rotation of the rocket and the speed of rotation. Then you have the last layer of the neural network, which is the output. This output is the answer of the neural network, like the amount of rotation the motor needs to move. Between those two layers, you have the hidden layers. This can be as many layers as you want. The more layers it has, the more powerful it will be, but also the harder it will be to train. These hidden layers have the function of doing the heavy thinking. So, between the layers there are connections. All these layers are connected in a very specific way. Every neuron of a layer is connected to every neuron of the next layer, and so on. The connection between one neuron and another is called a weight. Here I am highlighting just 3 weights as an example, but all the arrows are a unique weight. Okay, so what do I mean by weight? Weights are the value that is changed when the AI learns. And after the value of the weights are set right, the neural network will make the right calculations to get the correct output. When you connect two neurons, the value of the first neuron is passed to the value of the second neuron. But before passing it, it is multiplied by the weight between the neurons. Here it is 4 times 3, which ends up being 12. But that is not all. Then, to get the final value of the second neuron, you sum all the results that you got from multiplying the previous neurons to the weights. In this example, it is 4 times 3, which equals 12, plus 2 times -2, which equals -4. So it ends up being 12 minus 4, which equals 8. When you are done with training your neural network, its weights need to be perfectly set so that with each set of inputs, you get a correct output. But setting the value of the weights correctly is very hard to do. Usually what people do is train the AI with an algorithm. There are multiple algorithms you can choose from. Training the AI means setting the value of the weights. These algorithms to train the AI always need a lot of data of correct inputs and outputs, or lots of attempts at completing a set task. All this complicated shit is to simply say that you have input neurons, then a lot of complicated math goes on in between, and you get your output neurons. The hard part is training your AI so that it knows how to do the complicated math in between. Okay, so now let's do the simulation. So I will start by creating a rocket and the AI that controls that rocket. The input that I will give the neural network so that it knows what is going on is the rotation of the rocket, the rotation of the motor, the time since the last frame, the speed of the rocket, and the direction it is moving. The output that I will get from the neural network is the rotation that the motor needs to point to so that the rocket can be controlled. Done. So by just doing that, the AI doesn't know how to go up. So I will create 324 rockets, each with its own randomly initiated AI. So it looks like some do know how to kind of go up. Now I'm gonna make them look pointier. That should work. Yeah, I should add some AI training algorithm. After a bit of coding, let's see if they improve over time. I am going to track the average height of all rockets per generation. Okay, so this is very good. You can clearly see how they improve and start to learn how to go up. At first, the improvement is very fast, and it starts to slow down at around generation 12. Okay, but it still keeps an upward trend. This is the usual pattern you get when training neural networks. At the beginning, it starts improving fast, and at the end, it starts flattening out. It resembles an exponential decay curve. So, how did I make the rocket's AI learn? I used a neural evolution. It is a type of genetic algorithm that mimics actual biological evolution. So you know how evolution works. The fittest survive, reproduce, and pass on their genes to the next generation. Over generations, small random mutations in these genes lead to changes in the offspring. The training process for the rocket's AI works like that. Each rocket is equipped with its own unique neural network, leading to different behaviors. At the start, most rockets act unpredictably, much like early life forms on Earth. The rockets get 20 seconds to perform before we decide who gets to reproduce. When it's time, we rank the rockets based on the height they reached. Reproduction chances are then decided by their rank. The best rockets, like the fittest animals in nature, have a higher chance of passing on their genes, in this case the weights in the neural network. Then, two rockets are selected to reproduce, their weights get combined. We also introduce some mutations, changing a few values of the weights here and there. This ensures that the next generation of rockets will behave slightly differently. By continuously selecting the best performers and allowing them to reproduce, generation after generation, we eventually end up with the most optimized rockets possible. We can see that the rockets don't fly perfectly straight. This is because of some problems when training the AI. The final goal is that the rocket is capable of flying straight up and then land straight down. But first, we need to make some improvements when training the AI. Okay, so I am back after some days of trying to train it. It is a very slow process because every training session lasts about 10 hours. After trying a lot of different things, like changing the neural network size, adding more inputs, adjusting the mutation rate, and trying other ways to select the rockets to reproduce, I am done with the training. Now they fly perfectly straight. So now let's try the landing. Okay, so I am back again after weeks of training the AI to land down. I had 20 different tries changing different things to the neural network, but none of those tries worked. Probably if I trained it more time, it would end up working. But my solution was easier. I used a simple algorithm that stabilizes the rocket. This algorithm is used across all industries and it is called PID control. I am not going to explain it deeply, but it considers the rotation speed of the rocket, and the time it has been pointing sideways to calculate the rotation the motor needs to have. From this we can take that it can be very hard to train an AI with just evolution, because evolution is just trial and error, but most times ends up in error, so it ends up being a very slow process. For simple tasks like this, it is generally better to just use a plain old algorithm. Training AI is very costly and slow, and it is not as simple as giving it a task to complete and just train it for a very long time, because AI tends to improve towards the easiest path, but not towards the most optimal path. This is why architectures like transformers, the architecture used for GPT, are very important for AI to improve in an optimal way, so that it doesn't get stuck. I hope you liked the video. Goodbye. Thank you for watching.